Hi ladies, this is Mrs. Blaufuss here, and this is lesson 5.5. And in this lesson, we're going to look at some triangle congruence shortcuts. So if you remember from our previous lessons, we said that in order for triangles to be congruent, all sides and all angles had to be congruent. Well, now we're going to look at that, and we've developed a few postulates that prove that triangles are congruent without having to show that every single side and every single angle is congruent. So our first postulate is called the side-side postulate, side-side-side postulate, and in this postulate we say that if three sides of a triangle are congruent to three corresponding sides of another triangle, then the triangles are congruent. So by saying that three sides of one triangle are congruent to three corresponding sides of another triangle, we can say that the triangles are congruent. The triangles being congruent means that all three sides and all three angles are congruent. Okay, so we don't actually have to show that all angles are congruent. Just by showing that all three sides are congruent, we can show that the triangles are congruent. So in this diagram, we see that AB and our S are congruent. We see that BC and ST are congruent. And we see that TR and CA are congruent. So just by having those three sides congruent to three corresponding sides, we can say that the entire triangle ABC is congruent to the triangle RST. And once we say that the triangles are congruent, now we know that all of the angles and all of the sides are congruent. Okay, the sides are given, but since we can show the triangles are congruent, now we know that the angles are also congruent. So let's look at this example. It says two triangles, PQ and ML are congruent, PR and MN are congruent, and RQ and NL are congruent. We need to write a congruence statement for the triangles. The first thing I would do in approaching this problem is to make my triangles. Okay, I'm just going to draw two triangles. And it doesn't really matter how I draw them. I'm just going to draw them scalene acute just because that's, for me, just how I like to look at triangles. It doesn't really matter how you draw the triangles. Okay, so now I'm going to go ahead and label my points. So I know that PQ is congruent to ML. Okay, so I'm going to go ahead and label those segments congruent. And then I also know that PR is congruent to MN. And I'm going to go ahead and label those segments congruent. And then lastly, I know that RQ is congruent to NL. So I can label those segments congruent. Now I can write my congruent statement. And it doesn't really matter which letter you start with, as long as in the second triangle, you start with the corresponding letter. Okay, so here I'm going to start with P, and I'm just going to go P to Q to R. So P, Q, R is congruent. So P to Q, that's my one tick mark segment. So I have to start with my one tick mark segment. Okay, so M to L. And then Q to R, this segment right here, is my three tick mark segment. So I have to go to my three tick mark segment, starting with L. So I have triangle PQR is congruent to triangle MLN. That's another reason I like to draw out my triangles, because I like to draw them in the same orientation. So Q is on top in my first triangle, I'm going to put L on top in my second triangle, okay, because those are the corresponding angles. Now in this statement, all you really know are the corresponding sides. You don't know which angles correspond until you actually write your congruent statement, or in this case, until you actually draw your visual aid. So in the next example, please pause the video while you work, and you can unpause for the solution. Try this one on your own. Okay, so in this example, I'm gonna again just draw my two triangles, and it doesn't really matter where you start, but I'm gonna start with ZY on the left. And then I can go ahead and draw another triangle, and in my second triangle, I'm gonna have FE, because FE and ZY are congruent. Then this next point I'm gonna label is XY and DE. So XY and DE are congruent. And then lastly, XZ and DF. And then when I write my triangle congruent statement, I can say triangle ZYX is congruent to triangle FED. That's one statement you might have. Now, depending on where you started when you drew your segments, you might have another statement, but the important thing to remember is that corresponding parts have to line up. So ZX is congruent to FD. So ZX and FD, those have to be in the same orientation, okay, because that's what your congruent statement says. So another way you could write this same statement or the same triangle congruence statement is you could say triangle YXZ is congruent to triangle EDF. Okay, that works too. Or lastly, we could say that triangle, let's choose a different color, that triangle, let's start with X. We could say triangle XYZ is congruent to triangle DEF. Or you could say triangle XZY is congruent to triangle DFE. Okay, it doesn't matter the order that you write the first statement in, the first triangle, as long as in your second part of your statement, the corresponding parts line up. So in any of these, I should be able to see that these statements are true. Okay, so in any one of these, I should see that XY is congruent to DE. Okay, so here's XY, that's congruent to DE. XY here is congruent to DE. So they have to be in the same position of your statement. Okay, let's look at this next definition. This definition is included angle. And an included angle of a triangle is the angle that's formed by two sides. Okay, that's called an included angle. So the first shortcut we looked at was the side, side, side triangle congruent shortcut. The second one is going to include this included angle. So for example, angle A is an included angle of sides AB and AC. Okay, so A is in between sides AB and AC. We could say that B is also an included angle, but B is the included angle of sides AB and BC. Okay, so AB and BC come together to form angle B. And then lastly, we can say angle C is an included angle of sides AC and BC. So AC and BC come together to form angle C. Okay, so C has to be between the two sides that make that angle in order for it to be included. So using that definition, we can define the side angle side postulate. So SAS, that means side angle side. So the side angle side postulate says if two sides and the included angle of one triangle are congruent to the corresponding sides and the included angle of another triangle, then the triangles are congruent. So the key part here is included angle. Okay, so for example, angle A is the included angle of AB and AC. And here, angle R is the included angle of RS and RT. So the two sides that I'm given in triangle ABC are AB and AC, where A is the included angle. And in triangle RST, the two sides I'm given are RS and RT, where R is the included angle. Okay, so I can use the side angle side postulate to determine that triangle BAC is congruent to triangle SRT. So again, there are several ways you can write this congruent statement. I could also say triangle ACB is congruent to triangle RTB. Okay, so in any way that I write it, my angles have to match up and my sides have to match up. So here, AB and RS matches to AB, oops, this should say RTS, matches to AB and RS. Okay, and then lastly, RT and AC should match. So RT and AC, they have to be in the same order in each statement to show that the corresponding parts are congruent. Okay, let's look at this last example. And in this example, we're determining whether or not the triangles are congruent. So we have the two triangle shortcuts. We have side, 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 or side, angle, side. Okay, so if we're given all three sides of a triangle congruent to all three sides of another triangle, then we can show that the triangles are congruent by side, side, side. To use side, angle, side, remember we have to have the included angle. Okay, so let's look here. We have a side, WO, and a side, YZ. We have an included angle, Z and O, and then we have a side, MO and XZ. When I write congruent statements for triangles, I'm just going to leave some blanks just so that I can make sure I match up the corresponding parts. So inside angle side, and you can do this a different way if you choose, but the important part is that corresponding parts match up. So I'm just going to start with a segment because side, angle, side, first we have a side, then we have an angle, then we have another side. Okay, so I'm going to start with my side, W, or this looks like a V, so we'll use VO. Okay, so I'm going to start with that side. Then I'm going to look at my second triangle, and let's see which side matches to VO. And it looks like YZ is the congruent side to that. Okay, next I'm going to look at my angle. Okay, O and Z. And here, O and Z, those are both in the middle, so we're good. And then lastly, I'm going to look at my last side. So ZX and OM. OM and ZX. Okay, now I've shown that VO and YZ are congruent, angle O and angle Z are congruent, and segment OM and ZX are congruent. So that's my congruence statement. Okay, now let's look at the second diagram. And here I have a side, I have an included angle, and I have another side. But here I have a side, and this is not included. And it's not included because I don't know DE. Okay, in order for D to be an included angle, I have to be given FD and DE. So in this one, I cannot determine whether or not these triangles are congruent. Okay, I can't use side, side, side because I don't have all three sides, and I can't use side, angle, side because D is not an included angle. In order for me to determine whether or not these triangles are congruent, I would need one of two things. So I need to know, first of all, I could be given the included angle. So if I know that angle F is congruent to angle P, then I could use side, angle, side. I could use side, angle, side for that. Also, if I knew that DE was congruent to PR, I could use side, angle, side. Okay, because then I would have QPR with angle P as the included angle, and I would have DFE, where I would have, FDE, FDE, where I knew that D was the included angle, and FD and DE were the sides. Or if I wanted to use side, 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 I would need to know what this third side was. Okay, so I would need to know that QR was congruent to DE. Okay, then I could use side, side, side. But without any of those extra pieces of information, I cannot determine whether or not the two triangles are congruent. So please jot down any notes or questions that you have, and we can answer them next time I see you in class. Thank you.